Public libraries, which contain extension methods, still need to bear in mind the best practices that I've outlined in this module, but the priority of the guiding principles does change. The most important thing is making them resilient to future breakages, because a popular NuGet package has a life of its own, and you do not want to break a million developers' apps when they update some other dependency. You also need to keep out of the way, so make sure your extensions are hard to use by mistake. Easy to discover is not so important in this scenario, because typically your extension methods will be about functionality in other parts of your own NuGet package, so it's okay for consumers to explicitly bring them in. Now, before you skip to the end of the module because you don't publish NuGet packages yourself, this applies to you too, because it affects consumers of packages. In the next demo, I'll walk through two of the most popular NuGet packages and show you how they use extension methods to give users a consistent experience across large libraries which have been broken up into several packages. That's a useful way to think about package design and application architecture. The approach is to have one core package with all the common functionality, and then additional packages for the variations that you support. I could apply that in my message queue library, having org.messaging as the main assembly, with an extensions assembly for shared functionality that applies across all queues. And then I'd have separate assemblies for each message queue technology that I support: MSMQ, ZeroMQ, NATS, Redis, and so on. Using a message queue is pretty standard, so all that logic would live in the main libraries. But setting up each queue is different, and would need different parameters and different types of configuration object. That config logic would live as an extension method in each queue library. So the common iMessageQueue interface would be extended with a configure extension method, which is defined differently in each queue project. That way, every queue can be set up using its own configuration approach, but consumers of the queue libraries get consistency. They expect to call configure on their iMessageQueue instance whatever type of queue they use. That level of consistency abstracts the differences between implementations and makes it super easy for consumers to navigate large libraries. And I'll show that in the next demo.